everyone. I'm going to be going over some of the questions for your fourth lab, Get Charged. So this lab was about two things. It was about hydrates and ions. So in the first part of your experiment, you dehydrated a hydrate, which is a salt that has water in it. So when you heated it up in your crucible, you removed all the water, and then after that, you placed it into water again and you watched it rehydrate. And you should have noticed that your temperature increased with the rehydration. This is because whenever the salt enters it, those salts bond with the water again, and that's a favorable energy conformation for the salt. Therefore, it then causes heat to be released as those bonds form. The third part, which is kind of the focus for the experiment, you're given an unknown compound of copper and chlorine, and you are then tasked to figuring out what the molar ratio of copper to chlorine of this compound. To identify this, you first start off with your initial mass, which was 1 gram for all of you, and you then precipitated out the copper of the copper chloride using the zinc wire and the acid. After you dried it off, you then got a copper mass. So in the hypothetical example I'm going to use, let's say you got a mass of 0.57 grams of copper. Now, using this, we can then figure out what our molar ratio of copper to chlorine is. And the questions for this lab kind of guide you through the process. So question 1 is asking you to determine the moles of copper that you have. So to do that, you're going to multiply the mass of copper by the inverse molar mass of copper. Or another way of imagining that is divide the mass of copper by dividing the molar mass of copper. And we set it up like this, you'll see that grams will cancel and you'll get left with your moles of copper. So for me, that would be 0.00897 moles. For chlorine, you're going to do a very similar thing. First, you have to figure out how many grams of chlorine you have. So if your compound was only copper and chlorine, if you take your initial mass and subtract your copper mass, you will get your mass of just chlorine. From there, you can again use the molar mass of chlorine to identify how many moles of chlorine that you have. And if you did your math right, you should find that the moles of chlorine in my hypothetical example would be 0.0120 moles of chlorine. So that takes you through the first two steps of this analysis. Step 3, it asks you to find the experimental ratio. So you can do that by dividing both sides, or both the moles of copper and the moles of chlorine by your moles of copper. And that will give you a ratio of 1 to however many moles of chlorine you have for every 1 mole of copper. So you take 0.00897 and you divide it by 0.00897. You'll get 1. And then you'll take your moles of chlorine, in my case 0.0120, and divide it by 0.00897. And you'll find that for every 1 mole of copper, I have 1.33 moles of chlorine. But are we able to have 1.33 of a chlorine atom? Keep in mind that atoms are whole. You cannot split them at all. So this is actually impossible. So we want to adjust our ratio until we only have whole numbers. So we can do that by finding some number to multiply it by to make it whole. In this case, I would multiply by 3, and I'd find that for every 3 atoms of copper, I have 4 atoms of chlorine, and that would be my molar ratio in this instance. You can have some really wonky numbers here whenever you're multiplying this, but just do whatever the math tells you to do, even if it looks really weird, because LabFlow will grade you based off of the numbers that you give it. For steps 4 and 5, we're making some observations. And step 26, whenever you had the zinc wire and the acid going. For part 4, it's asking you what evidence is there of a chemical reaction. So I want you to think about what you saw and how you know things are changing. Look back at your observations and what did you see that was changing in your compound that suggests that there was a chemical reaction, and then tell me what that chemical reaction is. For step 5, imagine if that aluminum wire that we used had an increase in mass after you put in that solution. What could be causing an increase in mass? Is it possible that we suddenly have more aluminum, or perhaps that maybe something else than aluminum wire after the fact? For part B of that question, imagine the opposite. What would it mean if our metal wire lost mass? Is it possible for the aluminum to dissolve? Is that something that can occur? Whenever you put something in another solution, can it react with it and go out into the solution? So consider that for 5A and 5B. Moving on to discussion questions. Step 1 asks you to identify what parts of the procedure could have caused an effect on the formula weight. So tell me the number from your procedure and then explain as to why that step could have caused a mistake in your formula weight. There's probably like 15 steps in here you could choose, but you need to give me a rationale for why you are picking the steps that you choose. For question 2, it wants you to think about other compounds you've worked with this semester. I have gone through the Liberty and identified everything you've worked with this semester. So we have copper hexaaqua, copper hydroxide, copper oxide, and copper sulfate are the 4 copper compounds y'all have used this semester. And they want you to identify what is the most common charge of copper, because copper can have a few different charges. Things like oxygen only really have a -2 charge, but metals oftentimes can have multiple different charges. So for instance, copper has +1 and +2. It can also have +3 and +4, depending on the circumstances. So I want you to go through these 4 compounds and identify which charge is the most common one based off the atoms that we have worked with. So you would do this by comparing the charge of whatever is bound to copper, and copper must balance it out if it doesn't have a charge. So I did the first one as an example. In this first example, copper hexaaqua has a +2 charge. It has 6 water molecules bound to a copper molecule. Now keep in mind water doesn't have a charge, so if this has a neutral charge of 0 and there's a +2 charge, if we do 2 minus 0, we find that copper must have +2 in order for this compound to have a +2 charge. So this is a copper +2. Find out for these other 3 compounds what is the charge on this copper, and then tell me what is the most common copper charge based off of what you've seen here. Question 3 is a bit more challenging. People often struggle with this question. As I've mentioned, copper has 2 common charges. Tell me what those are, and then explain as to why it could potentially have 2 charges. There's a lot of answers for this on the internet. Please keep in mind that I have been around the block and I know what people put down for this. So please do not plagiarize this question, as it's very obvious and I get people for it every year. I want you to try and summarize what you read online. Go read through a few of those articles and summarize what the key concept is. As a starting point, I've given you the electron configuration of regular copper. So you'll need to show the electron configuration of the 2 copper charges that you list in your answer to get full credit. So to reiterate, I need 2 things: the electron configurations for both ions you mentioned, and a reason as to why there may be 2 ion charges. And then finally, for question 4, they are wondering why might you have a non-whole number ratio? So I kind of already mentioned one of the reasons why there may be a non-whole number ratio, and we kind of adjusted for that. That's one potential reason. But what are some other reasons why your ratio may be off? Did we do this experiment perfectly? I mean, did we not have any steps where we might have had some inconsistencies? So keep that in mind and give an explanation as to why there may be some non-whole number ratio in your answer, because I doubt that y'all got a perfect whole number when you did your initial math. And that's it. So good luck on y'all's lab, and I will see y'all next week.